Namaste everyone. My name is Bhavani. I am chemistry teacher. Today I want to share especially few important things about one of the simplest atom of element which is present in modern periodic table. It is very small atom of element with atomic number 6. It is a non-metal. I hope already you guessed what is the atom of element? Carbon. You may get doubt. Many atom of elements are present in the nature. Why this carbon becomes more popular? Because every living thing, the main constituent element is carbon only. Our human body is also made with carbon. The main constituent element is carbon. Not only this one, many important things what we are using in our day-to-day life, many articles, many things you can see on the screen, right? See, everything is made with the main constituent atom of element is carbon, and fuels, and food, books, nail polish, removers. And if you observe, coal, petroleum, graphite, diamond, the main constituent element is carbon. Carbon can form millions of compounds rather than any other atom of element because of its chemical bonding only. That is the reason today I want to explain what is the speciality of the bonding in carbon. Before that, just we need to recall a few things about atom of elements and stability. In nature, 118 atom of elements present, but among those, very few atom of elements are highly stable, chemically inert because of their electronic configuration. Before two atom of elements present, neon, argon. Not only this, helium, neon, argon, krypton, xenon, all these are called noble gases. They are chemically inactive and they are highly stable because they have 8 electrons in their valence shell. If you observe neon, if you observe argon, these two atom of elements have 8 electrons in their valence shell. If any atom of element has 8 electrons in its valence shell, that is highly stable. That is the reason remaining all the atom of elements try to get stability by losing electrons or by gaining electrons in many ways. Let us see how carbon can get stability. This is the electron dot structure of carbon. Nucleus, this is K shell and this is L shell. L shell means valence shell consists of 4 electrons. So carbon needs 4 more electrons to get octet configuration like neon. Another chance is there by removing electrons also. So carbon can gain stability by gaining 4 electrons or by losing 4 electrons. Let us see the possibilities what happened by gaining 4 electrons and by losing 4 electrons. No need to draw the entire electronic configuration. Just we can show the electrons as dots around the carbon atom, that is called electron dot structure. Okay, this is carbon. This is the outermost shell I am drawing. Consists of 4 electrons. 1 electron, 2, 3, 4. The nucleus consists of 6 protons. This is L shell. Okay, the nucleus with 6 protons hold 6 electrons very tightly. So now I am giving 4 more electrons to get stable configuration. So 1 electron, 1 electron, 1 electron, 1 electron. Now nucleus consists of 6 protons and atom consists of 10 electrons. Nucleus with 6 protons can hold only 6 electrons. But here 4 extra electrons are there. The nucleus cannot hold the remaining electrons. That is the reason atom is highly unstable. So this attempt is failed. Gaining of 4 electrons to form C4 minus anion, this attempt is failed. Now let us see another attempt. By losing 4 electrons, what will happen? The nucleus K shell consists of 2 electrons. Just we can show valence shell, no problem. L shell consists of 4 electrons. If we remove these 4 electrons, this carbon can get the stability of the helium. Now let us try. 6 protons hold the remaining all the electrons very tightly. If you want to remove the one electron, we need to supply some amount of energy which break the attractional force between the nucleus and the outermost electron. The nucleus hold all the electrons tightly. If we want to remove the electron, we need to break the force of attraction between that particular electron and the nucleus. That is the reason we need to provide some amount of energy, that is called ionization potential. Okay, we remove. In the same manner, we need to provide large amount of energy to remove all these electrons. But here is the problem. By supplying this much amount of large amount of energy to carbon atom, the atom become highly unstable. The atom become highly unstable. It is not possible to remove all the four valence electrons from the carbon atom. So, if carbon lose 4 electrons, carbon can form C4 plus cation. But this attempt also failed. This attempt also failed. That is the reason. This is the problem of carbon. This is the problem of carbon. Carbon cannot gain 4 electrons, cannot lose 4 electrons. So, carbon share its valence electrons with the other atom of elements like this. Now, let us consider simple molecule. Carbon consists of 4 valence electrons. In this molecule, carbon share its valence electrons with 4 hydrogen atoms. If you observe carefully, carbon got the stable configuration like neon. Individually, hydrogen also got the stable configuration like helium. Yes, right? In this sharing among the electrons among the carbon and hydrogen, all the atom of elements got stability. So, this is the chemical bond which we call it as a covalent bond. The bond formed between two atom of elements by completely sharing of electrons, that is called a covalent bond. In this case, carbon share its 4 valence electrons with 4 hydrogen atom. So, this bond is called covalent bond. That is the reason this molecule is called covalent compound. I hope you understand. And I want to show 3-dimensional picture of methane. Methane is the simplest hydrocarbon. Simplest, that is the first member of hydrocarbon, simplest hydrocarbon. The middle atom of element is carbon. 4 hydrogens attached to the carbon atom like that. It is 3-dimensional model of a simple molecule methane. You may get doubt. Only carbon form covalent bond, otherwise any other atom of element also form covalent bond. Yes, remaining few atom of elements also involved in the chemical bonding like a covalent bond. Now let us see one more example, formation of chlorine molecule. Already we know chlorine gas. Yes, chlorine gas is present in the nature, but in many chemical reactions, chlorine gas is evolved. Let us see how chlorine molecule is formed. You see, if you observe chlorine, its electronic configuration, if you observe the electron dot structure, this is the valence shell. Valence shell consists of 7 electrons. If it gets one more electron, definitely it gets stable configuration. That is the reason 2 chlorine atoms share their valence electrons, they form chlorine molecule. I hope you better understand the covalent bond, especially bonding in carbon.